Hey everybody. This video will be on metals, nonmetals, and metalloids. Um, we had talked about elements and compounds, the differences, and we also talked about physical and chemical changes. So now we're moving into, this is kind of moving into really Unit 2, where we talk about how the elements on the periodic table, how they're grouped on the table, how they're organized, how they're classified. Those are all words that represent putting these elements into different categories based on their similarities. What I want to remind you to do is on your digital notebook, you should have this whole section done on elements and compounds. You should have physical and chemical changes done. And then you should be moving into this section. And if you notice, you're going to have some fill in the blanks, and you can rewatch this video whenever. But, because this is a lot of vocab in here. But we're going to talk about properties, properties are like their background, what they're composed of, what they do. So metals, nonmetals, and metalloids, we're going to talk about all that. And then we're going to talk about 3 uses for them, because I did tell you how these elements on the periodic table, they make up everything found on Earth. Pretty neat. But what we're going to do now, we're going to more so focus on the fact that, they're based into these groups. And if they're organized into these groups, what then do we use these for on Earth? Okay? Just some common ones. There's many more out there, but common ones. Okay? So let's move into the slideshow here. So metals, nonmetals, and metalloids. This is just beginning stuff. So physical properties of metals, nonmetals, and metalloids. And you have to kind of think, going back to that periodic table of all the elements that we had talked about. Excuse me. But these physical properties, they can, and I'm kind of read this, so just follow along with this slide. They can be observed and measured without changing the composition of matter. Some of the properties of metals, nonmetals, and metalloids are going to be their appearance, their texture, their color, their odor, their density. Now, this is going to be a big word that we talk about, okay, because you guys don't really know what it is. But what I can tell you right now is that it's going to involve sinking and swimming, okay, like sink or float type stuff. And just to let you know that in chemistry, which is the unit we're in, there's going to be some math in science. Now, for those of you who are going, it's okay, because we're able to use a calculator in science, unlike your math classes, and the math is not as hard as in your math classes, okay? So just note that we are going to have some math coming up, but hopefully being able to use a calculator will kind of make it easier. Excuse me. But luster and then conductivity. So luster is like the element's shininess, light reflecting off that element. Conductivity is, how well it conducts electricity. And malleability, how it can be stretched, and think about the word malleable. You can mold it, kind of almost like taffy, if you will, in a way. And then we have ductility. So moving forward into the unit, we're going to go over those vocab words. So when I said luster again, that's like the shininess, or it could honestly be the opposite, like the dullness. This element here, do I know what it is offhand? No, but it's very dull. It doesn't really have any shine. It's almost like chalk. Whereas these ones shine a lot, and we probably know this one is gold. Ductile. I didn't even talk about that one, but this one is how a metal can be stretched into a wire. Like copper, you can take it and, you personally can't take it, but scientists and people out there that have the correct machinery, this element can be taken and stretched into wire. Similarly to why this could be found in some of the wires found in your home. Malleable. Well, this refers to like hammered into thin sheets, can be like, you know, I kind of think of like taffy in a way, but when they refer to metals and nonmetals and metalloids, they're more so talking about like the fact that you can like really make it into thin sheets. And a great example of this is aluminum foil, like what your mom uses to cook with. That's a really awesome example. Brittle. Now this is how something can shatter. We know that if we drop glass, it's going to shatter. You know that if you drop sidewalk chalk on the driveway outside, it's going to shatter. Okay. We know that those types of things, when dropped on the floor, are going to shatter. All right. It's a material that's very fragile and will fracture if, you know, has like a great amount of force on it. So those are good examples of the word brittle. Conductivity, how well like heat can pass through that material. It's going to make an electrical charge. These are great examples, light bulb and like on top of a stove. Insulator, it's a material that keeps energy such as electricity, heat, or cold from easily transferring through. Now, a lot of the wires like found in your home, ones even around the TV and stuff, ones that you use for your hair straightener and all that stuff, heat can pass through, but like if you touch the cords, you're not going to get injured because the covering surrounding it. Okay, so it's going to keep that heat from coming through. Alrighty. So metals. On the periodic table, we're moving into metals now. Most of the periodic table is going to be your metals. They're mainly found like in the middle section, and most are going to be solids. Okay, so most of these will be solids. You can, like this next slide here, you'll probably want to pause and on your sheet, like, you know, type in some of the notes, and you can shorthand it, meaning you don't have to type out everything here, but type in like keywords like luster. If you know it means shininess, you don't have to write shininess, but if you don't, you might want to write both. So we know that physical properties of metals, they're going to be super shiny or have a great amount of luster. They are awesome conductors of heat and electricity. They're going to have a high density, so more than likely, most of these will then sink. Okay, they're going to have a high melting point, meaning it's going to have to be like a really high temperature to melt. They're going to be ductile. A lot of them can be stretched into thin wires, like that copper example. And they're going to be malleable, similar to the aluminum foil in this picture, into really thin sheets. Okay? So again, pause and fill that out in that section. Some common uses of metals. Now, when we talk about this section on your notebook, you're going to fill in the metals uses right here. Okay? Okay, so copper. Like an example of a metal is copper, and it's used in coins and wiring. Okay, gold, that's a metal. It's used in jewelry and fillings. Lithium, you may have even seen commercials where it even says like lithium batteries, and batteries are made from lithium, and they're medicine. Yes, some medicines have metals in it, and not like it's going to hurt you, but in small amounts, it's perfectly fine. But if you notice, these three elements are found on the periodic table, and they make some of the things we use in our daily life. Pretty interesting, huh? So moving forward then into the non-metals, so like you might want to make sure you pause and fill in those sections of the notes. And then for non-metals, they're going to be found to the right of like this little stair step area, it's going to be all these ones over here on the side. So these are going to be your nonmetals, alrighty? Their properties are really going to be the exact opposite of the metals. Like whatever metals are, nonmetals will not be. Most of these over here, the nonmetals, they're going to be gases, okay? Like neon, for example, etc. Okay, so they're all going to be gases. Alrighty. So moving forward into physical properties of nonmetals. So again, pause, and you might want to fill in the notes here. You know, if you ever needed like more room too, you can add a slide. Like you could like click here and add a slide and just kind of continue some notes if you wanted to. So it's really easy. Like you just got to kind of think outside the box of how you want to do your notebook, okay? But on the video, once you're done filling in your notes, then listen to the properties of nonmetals, okay? So they're going to be very dull. They're not going to be shiny. Dull, okay? Like this picture, just dull, okay? They're going to not, like they're poor conductors. They don't conduct heat or electricity well at all. So they're just the exact opposite of metals. They're going to be brittle. They're going to break really easily. So you could think of peanut brittle or like this element here. You drop it and it just brittle, breaks so easy. They're not ductile. You cannot stretch them into long, thin wire like the copper from the metal section. They're not malleable. You cannot stretch them into thin sheets like the aluminum foil. They have a low density. More than likely, they're going to float. And they have a low melting point. Okay, so like not tons of heat and they'll melt. Moving forward to some of the uses, and on your notebook, you might want to go ahead and fill in the uses of nonmetals there. Would make everything a lot easier. So pause and fill that in, and then you can re-listen to the video or listen then. So here's an example. Oxygen. It is a nonmetal, and we know that we use it to live, to breathe, and it's used in like NASA, rocket fuel, etc. Chlorine. We know that chlorine can be found in pools, so like water purification, and in some pipes out there. Okay, so chlorine, that's another example of a nonmetal. Then we have helium. We know that helium is used in balloons. Okay, that's a great example. So those are just 3 examples of nonmetals and what we use them for in our everyday life. Okay. Now, when you're ready, then continue on to the metalloids. I usually call the metalloids like the oddball ones. Okay. Many of you are going to have questions like, what are these ones down here and off way to the side and whatever else? And you don't need to worry about those. These ones, if you notice like the pink, there's like a pink area here, and these aqua ones, there's like an aqua area right there. They actually are all these elements that belong right here. It would just make the periodic table look so weird if you put them all right here and then everything was just like all wacky and crazy. So they just take it and like made like a little legend, and everything's down here for those 2 areas, if that makes sense. Okay. And believe it or not, this periodic table is still growing. It's not over yet. Like, we can find more elements out there, and it could get bigger as the years go by. But the metalloids, I usually call the babies of the metals and nonmetals. And that's because it's going to have like properties of both metals and nonmetals, if you will. It's almost like the baby of both categories. So elements on both sides of the zigzag line have properties of the metals and nonmetals. So like this gray area is going to be your metalloids. An example is boron, and that's just a little saying like boron the moron is at the top of these stairs to help you remember if you want to remember them. You don't need to memorize this by any means, but it's just kind of showing you where everything is. Okay. Moving into physical properties of the metalloids. And again, on your notebook, you can type it in here. If you need more room, I would assume that you're either going to add a slide or you already have, and you'll kind of finish typing on the next slide. And you add a slide just by clicking the plus sign, okay? So on here, physical properties of metalloids. They're solids. They can be shiny or dull, okay? Like they can have a great amount of luster or nothing at all. They're ductile. They could be drawn into long, thin wires like the copper for ductile. They're malleable, meaning they can be hammered into thin sheets like the aluminum foil. And they conduct heat and electricity better than nonmetals, but not as well as metals. Okay? So these are like properties that like they share with metals and nonmetals, which makes them the oddball ones, the metalloids. Some of the uses, and on your notebook, you might want to fill in here where it says metalloids. And again, if you need more room, you'll add another slide. But the plus about like typing on your notebook is that you could go ahead and like if there's a certain size font in there, you can make it smaller if you can still read it, and all that good stuff. But here are 3 examples. So boron, it's going to give the green color in fireworks. Okay, kind of weird. Silicon, it's found in glass, okay, and it can be a semiconductor, meaning kind of a conductor, kind of not, if you will. And then arsenic. Some of you may even have heard of arsenic. It's a poison, and it can also give some color in some fireworks out there. But just kind of letting you know that those 3 examples are perfect examples of 3 metalloids that have properties of metals and the nonmetals, okay? That's really it for this video. Just remember to make sure you fill in your notes because this can be a confusing topic. It's an easy topic, but it's super confusing for you guys. And make sure that you go and fill in this middle section. You can go back and rewatch the video or pause and kind of, these are found more so towards the beginning. Yeah, for like vocab stuff. So I'm going to pause or stop the video and you can rewatch as many times as needed. Alrighty?